What makes a circuit breaker jump into action? Let's explore the spring-operated drive mechanism and uncover how all its parts work together, step by step. I'm AJ, and I love figuring out how things move and connect, just like these cool springs that power a circuit breaker. Let's start with the main players: the closing spring, the opening spring, coil carrier, damper, auxiliary switch, and the manual operation provision. Imagine springs as tiny power packs, holding mechanical energy until it's time to release it, like a perfectly timed jump. First, the closing spring. This is the muscle behind closing the breaker. It gets charged by a motor. Picture a small motor spinning, winding up that spring tighter and tighter. While the spring is charging, the breaker waits, like holding its breath. Animated springs can show this coil getting energized, storing energy for the big moment. Next comes the opening spring. When the circuit breaker closes, the opening spring stores energy for the reverse operation. It's like having a backup plan, ready to pop open the breaker whenever needed. Then, the coil carrier. Think of it as the messenger, carrying electrical signals to activate the springs. When AJ presses a button, the coil carrier rushes that message so the right spring can release and do its job. The damper is the silent protector, absorbing shocks and slowing the movement just enough so nothing breaks. It keeps the mechanism running smooth, like brakes on a bike. There's also an auxiliary switch. This clever piece gives feedback, making sure everyone knows if the breaker is open or closed. It's like AJ's voice telling you, "Mission accomplished." And when AJ wants to operate things manually, the manual operation provision lets him move the springs by hand, like winding up a toy. Now, let's follow the sequence, step by step. Step 1. The motor starts and charges the closing spring. The spring is wound tight, storing energy. Step 2. Once it's charged, the breaker is ready. AJ presses the close button, and the closing spring releases, snapping the breaker shut. Step 3. At the same moment, the opening spring is automatically charged, preparing for the next operation. Step 4. To open the breaker, AJ triggers the opening spring. It releases its energy, and the mechanism moves to open position. The auxiliary switch updates the status. Step 5. The damper absorbs any harsh movement, keeping everything safe and smooth. If AJ wants to operate manually, he uses the manual provision to charge and release the springs, flexing his engineering muscles. Each step relies on springs storing and releasing energy at just the right moment. Springs keep the mechanism ready and responsive, while switches and dampers ensure feedback and protection. That's the magic behind the circuit breaker's drive. With every well-timed jump, the circuit breaker keeps electrical systems safe. AJ's curiosity, and yours, powers the journey from confusion to clarity. Now you know the secrets behind the spring-driven circuit breaker.